Dear M1 students, dear everyone again, hi. Wishing you the best in these circumstances of Corona, and I wish you all the best. We are continuing our lessons regarding the circumstances. We are in statics of particles part 2. As we said in the first lesson in statics, or the previous video, that the diagrams or the problems that we are solving in statics are the same in dynamics, but in different steps of solving. It depends on the nature of the diagram. So let's start with doing 4 problems today. We are focusing on some examples of variant problems, past paper questions, different ideas. Let's start with the first one. First question says, a particle of mass 2 kilograms rests on a rough plane inclined at an angle alpha to the horizontal, like shown here. This horizontal and this is the angle alpha. Given that the coefficient of friction between the plane and the particle, so given mu is 0.2. It's true the particle is in equilibrium, or it is at rest on this plane. But to indicate to the student or the learner the direction of motion, look at the language used, and that the particle is on the point of slipping down the plane. This is the language to show the direction of motion in the equilibrium problems. So this is the direction of motion, down the plane. It's not moving. But if it moves, it's at rest. If it's willing to move, this is the meaning of this statement, it will go downwards, down the plane. Find the value of the angle alpha to the nearest degree, as we used to do before we start steps, solving the steps, starting the steps, we do resolve the forces on the diagram. So we start with the components of the weight. This is the vertical one or perpendicular one. This is the parallel one to the direction of motion. So this is 2g cosine alpha. This is 2g sine alpha. We have r perpendicular always to the plane. Since the plane is rough and the direction is down the plane, so we have friction up the plane, opposite to the main force. Good. Then we come to the steps. Parallel to the plane. Remember, parallel to the plane. The same steps. Write the steps that we used to write. Then the unknown will be found by itself. It will run itself. Try this to get the grades for these steps are counted. So start with the main force in the direction of motion parallel to the plane. 2g sine alpha is equal to Fr. Why I did this? Because we are in equilibrium. So again, this is supposed to be minus Fr equals 2 times 0, which is 0. A is 0, equilibrium. A acceleration is 0. So this implies that, my dear students, 2g sine alpha is equal to Fr. Perpendicular to the plane. R is equal to 2g cosine alpha. And the third equation, as usual, mu r, so f r is equal to 0.2 r. So we have three equations here. This is the first one, this is the second one, this is the third one. To be able to find the angle, what you have to do, we have unknowns here. To substitute an equation into another one. This is the idea in these questions. So now, by equations 2 and 3, what you will get? If r is equal to mu, which is 0.2, just replace r, this value here, in equation 3. So this that you'll be getting. Replace r by its value. So if r is equal to 0.2 times 2g cosine alpha. Now replace fr in equation 1. So this equation by equation 1 now, what you'll be getting? 2g sine alpha is equal to 0.2 times 2g cosine alpha. Notice we didn't see like this logic in the dynamics before. Rare questions, but they are common in here in statics. Now, depends on our steps, but we can do straightforward and fast steps. 2 with 2, the same values. G with G cancelling each others. Then you'll be having sine alpha is equal to 0.2 cosine alpha. So we have sine alpha and cosine alpha in one equation. We have to remember here. Remember that sine alpha, and this common idea in M1 problems, over cosine alpha equals to tan alpha. Tan equals sine over cosine. So to get the tan, we call this idea in this question the tan idea. The idea of the tan. So we divide both sides by cosine the angle to get the tan, dear M1 students. So tan alpha is equal to 0.2. So alpha is equal to tan inverse 0.2. With approximating this, he wants to the nearest degree. It's 11 point something, less than 5. It's 11 point exactly. .2. It's 11.3 almost. So alpha to the nearest degree is 11 degrees. The angle alpha, it's 11 degrees to the nearest degree, to the nearest units, to the nearest whole, to the nearest ones. Yes? Example 2, which is different question. This is different question. This one of the sample questions like came almost the same idea in January, last session. Not in the same topic, but the same idea. Question says a particle of mass m with uppercase kilograms rests on a rough plane inclined at the angle alpha to the horizontal as shown. A force of magnitude kmg, k is a number, kmg newtons is applied to the particle as shown in the diagram. As shown in the diagram. Given that the particle is on the point of moving down the plane. Show that, the question saying here, show that. K, this is the question, no solve, no calculator here, no calculating. Prove that, show that K is equal to mu cosine alpha minus sine alpha over cosine alpha minus mu sine alpha. Mu, since the plane is rough, mu is the coefficient of friction. This that appears in this expression or this relationship. Before we start proving or solving, we have to resolve the forces on the diagram. On the diagram. First, show the direction. Step 2, components of weight. So this one here, this one, the parallel component to the plane of the weight. So the first two forces we start with the components of the weight. Yes. This one is mg cosine alpha. This one is mg sine alpha. We are given external force in this question, dear students, which is kmg, in this direction. So we advise you many times, extend this force like this, extend it. So this is the force we are resolving. If this is alpha, so this is alpha. So its components are in different color. This force in red, its components one here, since the force is here, so it is downwards, yes, one here, which is what the one, the adjacent one is here. Since alpha is here, so this is the adjacent one. So this will be K M G cosine alpha, and we have here K M G sine alpha, and as usual we have R opposing or perpendicular to the surface or to the plane. R perpendicular to the plane. Then, as we used to write, step by step, we write parallel to the plane, we write the equations of motion now. Parallel to the plane. So since the direction of the motion is down the plane, we have two in the same direction. First one is mg sine alpha. Since there are two forces, we add them, plus k mg cosine alpha. This question seems hard. It's not hard. Just do it step by step. We are AS or A-level students. We must be good in algebra. Just write everything sufficiently, you'll be fine. Minus, since it's rough, so we have FR here. In blue, we have FR in opposite direction to these two forces. So it's minus FR is equal to 0. A is 0, equilibrium at rest. Since he said rests, equilibrium, these words means A is 0, given A is equal to 0. Perpendicular to the plane. Right, what must we write first, or we must write, then the steps will tell me what to do. R is equal to K M G sine alpha. We have another one for the weight, which is mg cosine alpha. What must we do here to replace? Substitute the same idea. Look, it's common idea. One of them one of them into the other one. What do I mean? We know that FR is equal to mu R. So FR equals mu times R. Write the value of R here in the third equation. So FR equals mu times K mg sine alpha plus mg cosine alpha. So this is equation 1, this is equation 2, this is equation 3. Now by equation 3 plus 1, equation 3 and 1, what you'll be getting? What are we doing? We are substituting FR in the first equation. Then that's it. Why? Look why. So this will give me mg sine alpha plus k mg cosine alpha minus mu km g sine alpha plus mg cosine alpha is equal to 0. Help yourself here by adding this or moving like usually we say. We don't agree in mathematics. I don't agree with as instructor in mechanics or mathematics by moving to say it. So by adding this to the other side, you will get mg sine alpha plus k mg cosine alpha is equal to mu times k mg sine alpha plus mg cosine alpha. Now we can notice that to make this problem easier to us, mg is common factor. So factorize both sides for mg. So mg is common factor on left hand side. So we'll give sine alpha plus k cosine alpha. Mg common factor, you will have inside here mu sine alpha plus mu cosine alpha. And we have k here, k mu sine alpha. So mg with mg cancel each other, it's the same. Since they are constants, if it's a variable, it's wrong in maths. Remember, we can't cancel, but m and g, they are constants, numbers, so we cancel them, is okay. Then what do I have here? What does the question want in simple language? Making k the subject. This is that he wants. So you have two terms with k. What do I have now? Sine alpha plus k cosine alpha is equal to k mu sine alpha plus mu cosine alpha. Then I have two sides with k. True. So this, by subtracting it here, moving this here, moving this other side. Let me use this language because we used to say it to make this faster, easier to you. So this will implies that k cosine alpha minus k mu sine alpha is equal to mu cosine alpha minus sine alpha. By writing k as a common factor on the left hand side, k is a common factor. So you have the in the brackets, inside the brackets, cosine alpha minus mu sine alpha is equal to mu cosine alpha minus sine alpha. Now to make K the subject, which is the last statement, the last step. So by dividing by this, so they will be getting mu cosine alpha minus sine alpha over cosine alpha minus mu sine alpha that he wants here. Some students, because students are variant, their levels are variant, some of them, it's boring, sir. We write so much. These questions come with 9 to 11 marks in the exams. So it's not long, it's not boring. Write everything clearly. And here we know this, that comes from this step, fourth step here. Write it again is okay. Write it again. By our experience, I'm teaching in the school and outside the schools, math learners, they lose marks in these questions because of a sign, because he doesn't or she doesn't want to write so much. No, write everything in details. You'll be saving time if you write everything right, my dear students. Let's move to a different idea. A particle of weight 10 newtons. A particle of weight 10 newtons rests on a rough plane that is inclined at an angle of 30 degrees to the horizontal. We have a horizontal force of P newtons is applied to the particle as shown. Given that the normal reaction on the particle is 18 newtons. Right, the question step by step. And the particle is on the point of slipping up the plane. Find the value of P in part A, part B. Since he said rough, so there is friction, so there is mu. In part B, he wants the value of the coefficient of friction. Part C, what does he want? He's saying if the horizontal force is removed, this P is removed. It's a very common idea in past paper problems. Determine whether the particle will move or not. Determine whether the particle will move or not. Step by step, the same thing. The same thing. He said P is horizontal. P is horizontal force, so this is 30 degrees, my dear students. Yes? Don't leave this force as it is, extended, like this. So this is 30 also. So this one is the adjacent one, which is P cosine 30. Which is the main force in this question, since it's the direction of the given direction of motion. So we have here, since this P is here, so the other component is perpendicular to the first one, which is here. So this one is P sine 30. P sine 30. Let me just do different colors. So this is P sine 30 and this is P cosine 30. Good. What do I have before? Before, what do I have? I have the components of the weight. I have the components of the weight. I have here 10. We are given the weight is 10 in the question. So you don't need to write M. Look here, I shaded, while we're shading here the particle, we are not interested in the mass, the value of the mass. We are given the weight of the particle. It's 10. So this one is 10 cosine 30 and the parallel is 10 sine 30. Simple like this. And we have R as usual perpendicular to the plane. These are the forces and the components of the forces acting on the particle. Then we come step by step to solve the parts of the question. Solution. Directly, we are free to start with. We have to be able, since we are seniors AS students now, while I'm reading the question, what I'm giving the question, R is 18. Yes, R is 18 in the question. R is the force, it's a force in perpendicular to the plane. So save your time and start with it, perpendicular to the plane. Try to start in simple English with the given ones. It will save your time. R is equal to P sine 30 plus 10 cosine 30. Since we are given R is 18, directly replace it by its value. So what we will have here, this implies that 18 is equal to P sine 30 plus 10 cosine 30. So one equation with one unknown that he wants in the part A. So directly we're calculating using the calculator. P is equal to 10 cosine 30. 10 cosine 30. Here, it's here, yes. So in one step, 18 minus 10 cosine 30 dividing by sine 30. So P is equal to 18.7 newtons. Part B, he wants the value of mu. From where mu will appear? From parallel to the plane. Look, when you are neat and write everything, you'll help yourself. P cosine 30 is the main force opposing two forces. It's the main force. Since it's rough. So where's the friction? The friction is here, in this direction, opposite to the main direction, opposite to the main force. So P cosine 30, parallel to the plane, component of the weight, which is 10, the weight sine 30 minus FR is equal to 0. Is equal to 0. This implies that FR is equal to P cosine 30 minus 10 sine 30. Yes? Minus FR to the other side, it will be FR by replacing 18.7 or P by 18.7. So FR is equal to 18.7 cosine 30 minus 10 sine 30. FR is, so 18.7 times cosine 30 minus 10 sine 30, which is 5 when you use the calculator. It's 11.2 newtons to 3 significant figures. And we are given R is 18 newtons. So the last step here, he wants mu. We know that mu is equal to FR over R. So 11.2 newtons over 18 newtons, which is 0.622 to 3 significant figures. Part C now. Part C is a new question, new part, my dear student. What does the question say? Question said, if the horizontal force is removed, so P in part C now, we are in part C now, What does the question? Sketch it again. What does the question say? P is no more. So what will happen? Sketch it again if you don't see it. 30 degrees, of course, will not change. So the particle, the horizontal force that was affecting here, P newtons, this one, it's removed now. P is removed. What will happen now? Since P is removed, it was helping or pushing the particle to move up the plane. Like they said, it's in the point of slipping up the plane. But now when remove this, of course the particle may move. Look at the language, may move down the plane. Because of this, he's not sure. He's saying we'll decide whether or not, we determine whether or not the particle moves. How we do this? Now since P is gone, P is removed now. P is removed in part C. What will happen? Only we have 10 times sine 30, 10 newtons, which is the weight, cosine 30, and we have R. Good. And FR opposing now 10 sine 30, which is down the plane. Is it moving or not? Will this particle move or not? We took this idea before the beginning of dynamics. Some students may wonder, say it's equilibrium. We know it's equilibrium. But now in this condition, when he said the horizontal force is removed, my dear students, he did change the question, new information, new part, new question. So what you have to do? We have to do this. We calculate the main force. What's the main force which is parallel to the plane? We know that 10 sine 30 minus FR. This is the mistake the students do. They write equals to 0 here. This is disaster. This is the problem. We don't know here. Be careful. So this thing in this particle, if you'll be writing the full equation, I have to write this equals MA. Because now it's accelerating. Now the particle accelerates. Now the particle accelerates. It's not in equilibrium anymore. It's not at rest. Force P was the external force before it has been removed, making the particle in equilibrium. Now it's not. So we don't know what's the value. So how do you do? We remember the first fact, we calculate 2 steps. The new FR now, we have a new value, which is mu R, and R is changed now. Mu, we know it, which is this value. So FR is equal to 0.622 times 10 cosine 30. We have a new value now, because P is gone. So when P is gone, its component is gone also. It doesn't appear. It will not appear. So you have a new value of the reaction, and FR as well, which is 0.622 times 10 times cosine 30, which is 5.39 newtons to 3 significant figures. This is the magnitude of R, of the friction force. Now, what's the value of this value? What's the magnitude of this value? It's 5 when you use the calculator. Now the main force, which is 10 sine 30 in the calculator, it's exactly 5 newtons. Now, since friction more than the main force, 5.39, it's more than 5. Students, they didn't watch the previous videos. It's in the second, third, or fourth dynamics videos on dynamics. Will the particle, I did a lesson on YouTube, will the particle move or not? We explained this well. So what do you do? So this is an old skill for the students, they watch the videos. Since the friction is more than the main force, so the particle remains at rest or will not move, remains at rest. It will not accelerate, it will not move. Particle will not move. The particle will not move in different language, will not move. The particle will not move. This is a third different idea. And common ideas. This is very common question in M1 exams. Let's move, my dear students, to the last one, which is different also. The question gives me two particles. One is a ring. One is a particle connected by a string. This one is a string, and this is a peg, like spherical shape, like the pulley. And this is a vertical wire, rough vertical wire. And this ring, as the question said, threaded on it. And this angle is 30 degrees. Let's read the question, just I showed you here. So its ring passes over smooth peg, is attached at one end to a particle of 3 kilograms, which is this one. So this is the peg here. And this is the ring. And the other end to a ring of mass 2 kilograms, which is this one. The ring is threaded on a rough vertical wire, which is this one. This is the wire here. This is the wire, as shown in the figure. The system is in equilibrium with the part of the string between the ring, between the ring here and the peg inclined at the vertical, or inclined at an angle 30 degrees to the vertical wire. Find the coefficient of friction between the ring and the wire, which is here. This is the motion here. Good. Before we start solving the question, what must we do? We resolve the forces in the diagram. Here we have some specific idea, special idea. You'll see now. So here, since this is the string, so this is T. So this is the adjacent component, focus here, and this one is the opposite one. So this one is T sine 30, and this one is T cosine 30. Simple like this. This is T cosine 30. And this is the same tension, and it's one string, he said. And this 3 G. The weight of the particle 3 m. He gives me the masses in terms of m. Before I do write, remember how to do these questions. Two particles. First step, we do the particle 3 m. We are resolving the forces on the particle 3 m. Since it's the heavier one, hangs freely like the diagram shows, so 3 mg. 3 mg is the main force, minus T is equal to 0. Is 0, dear students. So from this directly, T is equal to 3 mg newtons. 3 mg newtons. For the particle, 2m now. 2m kilograms. We have two cases, two components here. Because, focus here. Now, the direction of motion, the surface of motion, I'll do it in black to show it to you, is here, dear students. Here, do you see it? Not horizontal like we used to do. This is the difference between this example and the questions that we did. So, since the tension is here, and this is the component T cosine 30 is in this direction, because the T is in this direction. We have forces also acting. We have 2 mg, because this is 2m kilograms weight, and we have friction down, because the tension in the string is the main force in this. This will go down, so this is T, so this is the direction of T, so this is the adjacent component, this is the direction of the T, and this is the opposite one, comes like this. What do I have here? R, remember. So R in this case, remember we said this, and again I advise you, for the students that did not watch the previous videos, focus on this. Everything is written in details about these things. R is always perpendicular to the surface of motion. This is the surface of motion on the vertical now. So R in this direction. So when you write here, you come here and write horizontally. What are the horizontal components? They are R is equal to T sine 30, dear students. Not R is here, be careful. R is not here. R is not always in this direction. R is always making 90 degrees to the surface of motion. To the surface of motion. So by replacing it, the value of T in here, R is equal to 3 mg sine 30, which is, sine 30 is having the calculator, so R is equal to 3 over 2 mg newtons. Now, vertical components on the particle 2m kilograms, T cosine 30 up, mine equals to Fr plus 2 mg down. So Fr is equal to T cosine 30 minus 2 mg. By replacing T by its value, so T is 3 mg, cosine 30 is radically 3 over 2 in the calculator, minus 2 mg. Calculate this, or you keep it as it is. For now, I prefer this as a teacher or instructor of mechanics, because most of times, like the previous questions, come writing in terms of M and G. So I prefer not using the calculator, but it's okay if you use the calculator. But this will give you 3 radically 3 over 2 minus 2 mg. This is the value. At the end, we use the calculator as well, because he wants mu. He wants mu. Since now Fr equals mu r, so mu is equal to Fr over r. Fr, which is this, keep it, write it as it is. 3 radically 3 over 2 minus 2 mg over 3 over 2 mg. Now use the calculator. Why? Because G, we calculate the decimals, maybe you complicate the problem more. mg with mg cancel each others. 1 mg divided by itself is gone. Now use the calculator. You write 3 radical 3 radical 3 dividing by 2 minus 2 dividing by 1.5. Mu is 0.399 to 3 significant figures. We can say they are hard problems, but this one we have main difference steps and ideas. This is different because the direction of motion is vertical in here. It's vertical, different from most or all even the questions that we did before in dynamics and statics, both. So you have to read the question well, sketch the problems, remember the concepts, my dear. The concepts. Remember the concepts. R is always perpendicular to the surface of motion. So don't put R as we wish. Yes. If you have questions, you can communicate for the people subscribe the channel on YouTube. I don't mind, I will answer your questions anytime. And I wish you the best, and I wish you understand the problems today. And thank you so much for today.